Dear students, to find out a plane through the line of intersection of two planes, we make use of this formula. Suppose we have two planes. S1 is given by a1x plus b1y plus c1z plus d1 is equal to 0, and S2 is given by a2x plus b2y plus c2z plus d2 is equal to 0. Then equation of the plane passing through the line of intersection of these two planes is given by S1 plus lambda S2 is equal to 0. Remember, when two planes intersect we get a straight line, just as when two lines intersect we get a point. Okay, now let's take two examples based on this formula. First example, find the equation of the plane passing through the line of intersection of the planes x plus 2y plus 3z is equal to 4 and 2x plus y minus z plus 5 is equal to 0, and perpendicular to the plane 5x plus 3y plus 6z plus 8 is equal to 0. Now a plane passing through the line of intersection of these two planes is given by x plus 2y plus 3z minus 4 plus lambda times 2x plus y minus z plus 5 is equal to 0. Now this equation can be rewritten as 1 plus 2 lambda into x plus 2 plus lambda into y plus 3 minus lambda into z plus 5 lambda minus 4 is equal to 0. Now to find out the value of lambda, we make use of the condition that this plane is perpendicular to this plane. So we make use of the formula a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So we have 1 plus 2 lambda into 5 plus 2 plus lambda into 3 plus 3 minus lambda into 6 is equal to 0. So therefore lambda is equal to minus 29 upon 7. So put this value of lambda in this equation, equation number 1. We have required plane as 51x plus 15y minus 50z plus 173 is equal to 0. Let's take one more example. Find the equation of the plane through the intersection of the planes x plus y plus z is equal to 1 and 2x plus 3y minus z plus 4 is equal to 0, which is parallel to the x-axis and in the second part parallel to y-axis. So equation of the plane which passes through line of intersection of these two planes is given by x plus y plus z minus 1 plus lambda times 2x plus 3y minus z plus 4 is equal to 0, which can be written as x into 1 plus 2 lambda plus y into 1 plus 3 lambda plus z into 1 minus lambda plus constant term is minus 1 plus 4 lambda is equal to 0. Now it is given that this plane is parallel to x-axis in the first part. Now if the plane is parallel to x-axis, then normal of the plane will be perpendicular to x-axis. Now direction ratios of x-axis are 1 0 0 and direction ratios of the normal to the plane are 1 plus 2 lambda 1 plus 3 lambda 1 minus lambda. So therefore making use of a1 a2 plus b1 b2 plus c1 c2 0, because these two lines are perpendicular, so we have 1 plus 2 lambda into 1 plus 1 plus 3 lambda into 0 plus 1 minus lambda into 0 is 0. So therefore lambda is equal to minus half. Put the value of lambda minus half in equation number 1. We get required plane as y minus 3z plus 6 is equal to 0. Similarly, when the plane is parallel to y-axis, now direction ratios of y-axis are 0 1 0 and direction ratio of the normal to the plane are these 1 plus 2 lambda 1 plus 3 lambda 1 minus lambda. So therefore we have 1 plus 2 lambda into 0 plus 1 plus 3 lambda into 1 plus 1 minus lambda into 0 is equal to 0. So therefore lambda is equal to minus 1 upon 3. So put the value of lambda here in equation number 1. We have x plus 4z is equal to 7. Now we come to the next topic, homogeneous equation of the second degree. This equation ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy is equal to 0. This equation is called the homogeneous equation of the second degree in xy z, because you can see that in this equation each term is of second degree. Now this equation represents a pair of planes if ABC plus 2fgh minus af square minus bg square minus ch square is equal to 0. An angle between the planes represented by this equation is given by theta is equal to tan inverse of 2 times under root of f square plus g square plus h square minus bc minus ca minus ab divided by a plus b plus c. And these two planes are perpendicular if theta is 90 degree, and you know that tan 90 is infinity. That means denominator should be 0 in that case. So condition for two planes to be perpendicular is a plus b plus c is equal to 0. Okay, let's take an example based on these formulae. Prove that this equation 2x square plus 6y square minus 12z square plus 6yz plus 2zx plus 7xy is equal to 0 represents a pair of planes, and then we have to find the angle between them. So first of all, we compare this equation with the standard form of the second degree equation, which is ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy is equal to 0. So we have a is equal to 2, b is equal to 6, c is equal to minus 12, 2f is equal to 6, so f is equal to 3, 2g is equal to 2, so g is equal to 1, 2h is 7, therefore h is equal to 7 upon 2. Now put these values of ABC FGH in this equation, ABC plus 2FGH minus AF square minus BG square minus CH square. So this expression, when you put these values, is equal to 0. So therefore this equation represents a pair of planes. And to find the angle between them, we make use of this formula. Tan theta is 2 times under root of f square plus g square plus h square minus bc minus ca minus ab divided by a plus b plus c. So by putting these values, tan theta comes out to be minus 5 root 17 upon 4. So therefore theta is tan inverse of minus 5 root 17 upon 4. Now to find out area of a triangle in 3 dimensions. Suppose we have a triangle having vertices at x1, y1, z1, x2, y2, z2 and x3, y3, z3. Then we find these 3 determinants: delta x, delta y, delta z. Delta x is projection of the triangle on yz plane. Similarly, delta y is projection of the triangle on zx plane, and delta z is projection of the given triangle on xy plane. So delta x is given by half determinant of y1 z11, y2 z21, y3 z31. Similarly, delta y is half z1 x11, z2 x21, z3 x31, and delta z is half determinant of x1 y11, x2 y21, x3 y3 1. Then area of the triangle delta is given by under root of delta x square plus delta y square plus delta z square. Many times we don't have to apply this formula. We can directly use projection. Projection is also a triangle in 2 dimensions, and you know area of the triangle in 2 dimensions is half base into height. Okay. Volume of the tetrahedron whose vertices are the points A, B, C, D. Coordinates of A are x1, y2, z1. Coordinates of B, x2, y2, z2. Coordinates of C, x3, y3, z3. And coordinates of D are x4, y4, z4. So volume of this tetrahedron is given by V is equal to 1 upon 6 determinant of x1, y1, z11, x2, y2, z21, x3, y3, z31, x4, y4, z4 1. Okay, now let's take 2 examples based on these 2 results. 4th example. Through a point P, alpha, beta, gamma, a plane is drawn at right angle to OP to meet the axis in ABC. Prove that area of the triangle ABC is r to the power 5 upon 2 alpha, beta, gamma, where OP is equal to r. So in this case, first of all, we have to find out the equation of the plane which passes through P and is perpendicular to OP. Now direction ratios of OP are alpha minus 0, beta minus 0, gamma minus 0, that is alpha, beta, gamma. Now direction ratios of normal and direction ratios of OP are same because both are perpendicular to the plane passing through P. So therefore, using 1-point form, equation of the plane passing through alpha, beta, gamma and perpendicular to OP is alpha into x minus alpha plus beta into y minus beta plus gamma into z minus gamma is equal to 0. That means alpha x plus beta y plus gamma z is equal to alpha square plus beta square plus gamma square, which is alpha. That means alpha x plus beta y plus gamma z is equal to r square, because r square is, using this formula, r square is OP square, which is alpha square plus beta square plus gamma square. Dividing throughout by r square, we have x upon r square upon alpha plus y upon r square upon beta plus z upon r square upon gamma is equal to 1. Now this is equation of the plane in the intercept form. So clearly this plane meets the axis at the points A. A is on the x-axis, so y and z coordinates will be 0. So coordinates of A are r square upon alpha, 0, 0. Similarly, B is a point on y-axis, so its coordinates are 0, r square upon beta 0. And C is a point on z-axis, so its coordinates are 0, 0, r square upon gamma. Now we find out delta x, delta y, delta z. Delta x, projection of triangle ABC on yz plane, which is triangle BOC, which is half OB into OC, which is half into OB is r square upon beta and OC is r square upon gamma. So this is r to the power 4 upon 2 beta gamma. Similarly, delta y is projection of triangle ABC on zx plane, that is triangle COA, which is half OC into OA, and this is r to the power 4 upon 2 gamma alpha. And delta z is projection of triangle ABC on xy plane, that is triangle AOB, which is half OA into OB, which is r to the power 4 upon 2 alpha beta. So therefore area of the triangle is under root of delta x square plus delta y square plus delta z square, which is under root of r to the power 8 4 beta square gamma square plus r to the power 8 upon 4 gamma square alpha square plus r to the power 8 upon 4 alpha square beta square. Take r to the power 8 outside, becomes r to the power 4, take 4 outside, becomes 2, and inside the square root we have alpha square plus beta square plus gamma square upon alpha square beta square gamma square. Now this is r square, so square root of r square is r, and square root of this is alpha beta gamma, which is equal to r to the power 5 upon 2 alpha beta gamma. Now let's take last example. Show that the volume of the tetrahedron formed by the planes Lx plus My is equal to 0, My plus Nz is equal to 0, Nz plus Lx is equal to 0, and Lx plus My plus Nz is equal to P is given by 2p cube upon 3 Lmn. Now we have to find out volume of the tetrahedron. Now we know the formula for finding out volume. This is the formula. For using this formula, we must know the coordinates of the vertices. So first of all, we shall solve these equations to find out all the 4 vertices. If we solve equation 1, 2 and 3, we get coordinates as 0, 0, 0. If we solve 1, 3 and 4, we get these coordinates. Solving 1, 2 and 4, we get coordinates P upon L minus P upon M, P upon N. And similarly, when we solve 2, 3 and 4, we get coordinate as P upon L, P upon M, P minus P upon N. So therefore volume of the tetrahedron is, make this the formula, 1 upon 6 0, 0, 0, 1. Similarly minus P upon L, P upon M, P upon N1, then these, and then 1, then P upon L, P upon M minus P upon N1. Take P common from each row, so it becomes P cube out, right? And take L 1 upon L, 1 upon M, 1 upon N common from here, we get Lmn, and expand with this with respect to this row. So we get minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. So solve this determinant. Value of this determinant is 4. So we have 4p cube upon 6lmn, that is 2p cube upon 3lmn. Thank you so much.